In this video, we'll define what a parametric equation is and talk about why it might be useful if we're talking about different types of curves. The main idea for parametric equations is the point of I want to, instead of having to have y as a function of x, I want to be able to have both x and y be functions of t, and what you want to think of as time. So the idea is sort of that you want to follow a particle that's moving around the plane and use that as a way to write a function sort of thing for this curve. So for instance, if I have my particle that sort of dots around in this sort of a fashion where it moves around in a loop like this and then goes out this way, I can trace out the curve that this sort of followed as it went through its route. And now I want to describe that curve by tracking the particle as a function of time. So where is it after 1 second? Where is it after 2 seconds? Where is it on this loop? And using that sort of idea to determine how I want to write out and describe this curve. So the idea of that is we're going to define c of t to be the pair of functions x of t and y of t, where the x of t function describes where is the x coordinate at the certain point in time, and y of t does the same thing for the y coordinate, explaining where that is as a function of time. And the reason why we want this is because it lets me describe curves like the one above without worrying about the fact that it's not y as a function of x, right? In this case, this doesn't pass the vertical line test, right? This vertical line here hits the curve at multiple points. So it's not a function of x. However, if I write it as a parametric equation, i.e. in this form, I can write out this curve no problem. I can trace it out. It works just fine because I'm following the particle around as it moves around this loop. So if this is our curve C, capital C, will be the object that is this graph, this line you've drawn on the plane, then if C of t traces out this curve, we say that C of t is a parameterization of the curve capital C with parameter t. And then once we have this, we call capital C a parametrized curve. That is, it is a curve in the plane that I can write with a parameterization, so it is a parametrized curve. It has a parameter, this t, assigned to it for how the particle moves around the plane. Another way you can see these written out is in terms of parametric equations, which basically means I just want to separate the x and y and write them separately. So you'll write x is t squared plus 3t, and y is, sine of t, as opposed to writing t squared plus 3t sine of t. Basically, I just write the x and y separately, and you'll see this form as well used for these sorts of setup. You're not writing it as a parameterized curve or as this function c of t, but it's in these parametric equation forms. So one of the first things that you can do with these equations is try to sketch them out. And the point here is I'm just going to plot some points and then draw the line between them and let that determine what this graph's going to look like. We'll talk about other methods in the future. So in this case, we're going to start drawing a graph. And then we're going to make a table and start plotting points. So I have x is 4 minus t, and then y was t squared plus 2t, and then we have values of t. So if I plug in t equals 0, I get that x is 4 and y is 0. If I plug in t equals 1, I get that x is 3 and y is 3. If I plug in t equals 2, I get x is 2, I get 8. Now let's start going the other way with other values of t. So if I plug in, say, minus 1, I get 5 for x, and I get minus 1 for y. Minus 2, I get 6, and I get 0. And minus 3, I get 7 and 3. Now we can start plotting these points to see what I get. So I know the point 4, 0 is on my graph. So 4, 0 is here. 3, 3, which is here. 2, 8, and then minus 1, 0, and 3 again. And if you go to trace out this line, you'll see it looks like it should probably be a parabola, right? It's going to come down like this, minimum there, and go back up this way. We can try to graph these parametric equations just by plotting some points and seeing what they look like. The same way you could do to graph a function, but instead of just plotting x versus the y coordinate, you're now picking t values, plugging them into both x and y, using that to graph your function. That's the idea of a parametric equation. The idea being now I want to describe curves differently as both x and y as functions of t instead of y as a function of x, because that gives me more flexibility in what kinds of curves I can model with these functions. And in turn, it'll make some calculations a lot easier if we have this sort of way to interpret these curves using parametric equations instead of just having standard functions that we have to rely on to solve all these problems.